Hello, everyone, and thank you for joining this session. Software supply chain risks, are we forever doomed? My name is Simon Maple. I'm the field CTO here at Sneak and looking forward to giving this session. Thank you very much for the invite to the Visma Security Conference. So a little bit about myself first. I've been in the engineering space for over the last 2 decades. And very much on the Java side, doing a lot in the community with the virtual Java user group, the London Jug, and also groups like VismaSecCon to promote developer security. If you're interested in reaching out, my contact details are there on the left. So let's jump in. And if you're here today, it means you care about software, like all of us, I think, and you care about the security of your software. And you potentially very, very likely use open source software, and you care about the security of that open source. And today we're going to really be looking at how the open source software supply chain impacts us all. So let's take a moment to reflect on this picture and take a moment to think about what comes to mind when you look at this photograph. And well, for me, I mean, I'm wondering if it's a futuristic outlook of the world. And in recent times, we know the challenges of remote learning and remote tuition. Perhaps this is a great opportunity to use, IoT and robotics and ways for our children to learn more. However, this could equally be where does it get it from? Can this upstream source be compromised? What might happen if it did get compromised? Perhaps someone could hack in, watch the video feed, talk to my child. There are a number of things that come to mind in this. So today we want to share some real world stories, how developers play the fundamental role or a fundamental role in many of the recent and growing security incidents, why you should care about software supply chain security, and really leave you with the question of who do you trust and what do you trust? Do you trust certain maintainers? Do you trust certain packages from communities? Where does that level of trust need to stop and be thought about? So why don't we start by rewinding a little bit back in time and getting an early glimpse of how one developer perceived the risk of open source software. Back in 1984, Turing Award winner Ken Thompson wrote this short essay titled Reflections on Trusting Trust. And in it, he describes how he added a backdoor to the login program of Unix and went further to continue to add a backdoor into the C compiler, as well as the compiler to that C compiler. And in this revelation of how software can be taught to learn specific traits and pass them on to their spawns, he talks about how software can remain without a trace of a Trojan horse or effectively by the risk of or danger of trusting code that we didn't entirely create ourselves. And when we even say that, when we think about trusting code that we didn't entirely create ourselves, well, that goes from the application code to the libraries it uses, to the compiler, to the assembler, to the CPU. Where are the lines drawn? Now, as we learned from Thompson's Trojan horse story, that, as I mentioned, dates back from 1984, developers have been targeted as a vehicle to distribute malware and backdoors for a long time now. And we're going to explore some of those recent events, and starting off with abandoned packages. And when we think about abandoned packages, here's an example from some findings that an academic research paper published a couple of years ago, which investigated the properties of language-based software ecosystems and found that 61% of open source packages on NPM are abandoned based on the fact that they hadn't received any releases in the prior 12 months. That's almost 2/3 of open source libraries on NPM abandoned. That's really, really scary. Why is it scary? Well, let's take a look at what could happen to an abandoned library. And what we're looking at here is an incident that happened a few years back involving a package called Event Stream. This was the first, and this is the first time I would say that the NPM ecosystem witnessed its first high impact, very surgical attack based that targeted open source. And they contributed code and several pull requests, genuine pull requests, which benefited that library. Those were merged, and they then created a pull request which introduced another dependency, and this is the flat map stream dependency. At the time, it was a valid library, didn't have any malicious code in there at all. Now, the event stream library would consume the latest version of flat map stream, and a few weeks later, they added a code payload into flat map stream, which injected malware into a very specific Bitcoin wallet called Copay. And in fact, this was decoded, and it was only encoded. Sorry, it was encoded, and it was only decoded when used in the environment of the Copay wallet. So this is what makes it such a surgical attack. Now, the Copay wallet used event stream, and as a result, used the transitive dependency, the flat map stream. This went unnoticed for 3 months, almost 3 months, and the Copay wallet application released 2 versions which used the malicious version of the flat map stream library. And that included the malware as well. So, as if it could never happen again, as if this, we didn't learn anything from this attack. 1 year later, the exact same attack happened, and we'll see exactly how accurate this or how similar this attack was with the Electron native notify package. So what happened? Well, at a time, the Electron native notify package at version 1.15 was not malicious. It was just a package that did some stuff. Nothing that any maintainer, open source contributor would look at it suspiciously. A user adds it to EasyDex GUI. This is a package. EasyDex GUI is a package that the Agama crypto wallet used, and at that point there was no malicious code being used by the Agama or being consumed by the Agama wallet. However, in version 1.16 of the Electron native notify, some malicious code was added in, which, as a result of that connection with EasyDex, which the Agama crypto wallet was built upon, that was then consumed with the most recent builds, and as a result, a very targeted attack again to the Agama wallet was made possible through a very, very similar approach. So one of the things that we need to think about is not just to rely on our dev teams being careful about the dependencies they pull in, but we also need to have that same reliance on the maintainers of the direct dependencies and transitive dependencies for the libraries that they pull in as well. How do we maintain? How do we rely on those maintainers to uphold the same standards? Because those are the dependencies that they pull in that are eventually coming in to our libraries, our applications. So what about the tooling that we use to develop our applications? Well, how much thought are we giving to the security of our infrastructure, our development infrastructure? Resources potentially like cloud instances or staging environments, or the build tools, the CI tooling. Let's take a look at a specific example around the Visual Studio Code IDE. Now, a security researcher back in January of 2021 broke into the VS Code GitHub repository, essentially providing them with capabilities of making code modifications. So imagine that, a developer using a very, very popular IDE by Microsoft, which could potentially have malicious code in it that you are then writing your application code, your sensitive data. It's quite frightening. So let's look at what happened. Well, it was a command injection flaw that was made possible as an attack vector because of a flawed regular expression. And so this resulted in the researcher, by opening a new pull request, being able to execute code that the VS Code CI scripts was running without any authorization or any authentication checks being made. This essentially allowed the security researcher to have a remote reverse shell on the CI server, and as a result, being able to gain push or write access to the repository source code. So pretty frightening. And fortunately for us, it was a security response. It was a security researcher who was responsible enough to report this flaw to Microsoft so they can fix it before a malicious actor could exploit it. Let's take a look at a library now and jump into a very, very popular Markdown library called Marked in the JavaScript and Node ecosystem. And we'll take a look at how maintainers respond to vulnerabilities being reported. Now, this is a case study where if we were to look at the dates of when this was released, this security researcher opened a pull request, reported cross-site scripting vulnerability, included tests, proof of concept examples, etc., and they did this in 2015, in May 2015. However, when this actually eventually got merged and released into an official release, it was 2016, over a year later, without a fix. And this is how it is. This is what we should expect from open source software. Maintainers are just trying to do their best. This isn't the maintainers' fault. Maintainers can't be there all the time. They've got other things that they need to do. They have full-time jobs. They have other things needing their time. There's nothing legally obliging them, contractually obliging them to support you. So we need to understand what would happen if a library that we depended on had an issue that was disclosed publicly, and had that issue survived for a year without fix, what impact that could have on us, on our application. And secondly, of course, how are we being notified of a fix being available? How quick are we at then consuming that fix? What about maintainers? Let's go a little bit deeper into maintainers and think about the security hygiene on them. Because of course, we are very much reliant on the hygiene of our security hygiene of our dependencies, as well as the maintainers that look after those dependencies and packages. This is who we are putting our trust in now, not rather than what, as in a package, who are we putting our trust in? So in 2017, a security researcher working with the Node.js Foundation conducted some research to assess how weak NPM credentials were that were being used by maintainers. And the work revealed actually quite some devastating information about the lack of security hygiene. And we can see that they were able to gain publish access to 14% of NPM modules. And you can look at the list there in that second bullet: debug, MS, React. These are really popular packages that we depend on, absolutely depend on. 4 accounts from the top 20 downloaded modules. These are serious access that this researcher managed to get, and largely because the problem was rooted with insecure passwords. Well-known maintainer accounts using words like password or potentially reusing leaked passwords. This is something which is really quite dangerous, and we have to thankfully say this was research rather than something that a malicious attacker was doing. But I think it's absolutely possible for this to happen. So what can we do better? Well, if our code packages can reach thousands of millions of developers, should we have more protections in place? Well, how about two-phase authentication, two-factor authentication? In 2017, this was supported by the NPM registry, a registry that has obviously huge numbers of packages in its registry. Now, with that being available 2 years later, only 7% of maintainers enable 2FA on their accounts. So the vast majority only using a single password, potentially weak password, to protect their write access and publish access to those packages. How about a year later? Did it change much? Well, it's still not even less than 1 in 10 are still we're using two-factor authentication a year later. So what we can really learn from this is the supply chain story, the security involved in that supply chain. It's not a story that resonates well with developers, or enough with developers for them to actually do something about it. So what about a quote here from cybersecurity expert Bruce Schneier? He said in his book, Secrets and Lies, that humans often represent the weakest link in the chain. And I think that's really, really valid. When we think about open source, one of the nice things about that is that we have many, many humans looking at that open source. It's not something which is entirely closed off that just a small group look at. And in fact, a term which has been coined by coined as Linus's law, back in 1999 by Eric Raymond in his work, The Cathedral and the Bazaar in 1999, as I mentioned. He explored the differences between software development in an open source movement versus those that were more traditionally done in enterprises previous. And he stated that given enough eyeballs, all bugs are shallow. So given enough people looking at open source code, it should be easy enough to identify bugs and fix bugs. Is that true? Well, in January 2021, it was discovered that sudo, like very, very commonly used, as I'm sure you all know, utility that was installed on Linux distributions had a security vulnerability. And that security vulnerability meant that any unprivileged user could gain root access just based on the default sudo configuration. And that's what, and the biggest pain around this, which is quite daunting about this vulnerability, is that it was hiding in plain sight for over 10 years. And that's really, really interesting in terms of the idea that many eyeballs, all bugs are shallow. Well, this bug wasn't too shallow. So we all have to admit that we're part of an open source ecosystem. And as consumers or contributors or even maintainers, we play a part in a world where the vast majority, 80–90% of our application code is open source components. The question, of course, is, have we reached a point where we take open source for granted? Open source registries are very open in their nature, and they allow developers to push packages to them as often as they want. And we've become very accustomed to opening issues in project source code repository, asking for help, asking for a feature. But what happens when there are these unbreakable truths that are broken, like open source libraries? They'll always live in that repository. Well, that didn't happen when a maintainer named Azure pulled tens of his open source packages in npm.js due to a conflict that he had. And one of them was a very, very pivotal package, as I'm sure you've all heard of, LeftPad. It resulted in very, very widespread breaking of CIs, installed processes, basically the internet. Now, at the very least, this incident showed us a couple of things. One, that the weaknesses in how businesses fail to manage their open source software, this was a real soft spot in terms of the reliance that we had on packages existing in those repositories. But how registries didn't foresee this as a problem, to handle a circumstance where someone pulls a package that the ecosystem has a reliance on is kind of short-sighted as well. So what kind of malicious activities and assets can we track back to the ecosystems? Well, obviously there's malicious code that can be added in to disrupt the ecosystem, perhaps a typo squatting mistake, perhaps a dependency, as we mentioned previously, that was nested in a dependency graph, which someone plants with malicious content in. Either way, this just isn't a thing that only happens on the JavaScript ecosystem. In March earlier this year, over 3,000 malicious packages were added and published into the PyPI registry. And actually, this shows how attackers harness open source to their advantage. Alex Burson, in fact, published his research in February of 2021 that shows design flaws in package managers and registries and how they grab the actual packages. Corporations such as Apple, Microsoft, and many, many others were impacted significantly by dependency confusion. So in my remaining seconds, I'd love to leave you with the following questions. Are we going to have more or less software in our applications in future? Is that software going to be open source? And is that going to grow in our applications? And when we think about that, always think about who do you trust and what do you trust and whether you should trust them. Thank you very much for listening, and I'm happy to take questions.